All right, Drew, you're in the hot seat again.
Okay. All right.
So
Here we go.
the next topic is around CDNs.
Okay.
What do
I
you
know what that stands
know?
for a start. CDN is
Yeah,
Content Delivery Network.
yeah, nailed it.
Yeah.
It's a
Okay.
great.
Nailed it. All right. I'm gonna walk away. I'm gonna quit while I'm ahead. Okay. So you're
Now
okay.
explain to me, what is a CDN and what do we actually use these for in technology?
Okay, so content delivery networks are a way of not syndicating, sending information from a central repository to the endpoint where you need them. So maybe the most famous example would be Amazon Web Services.
Hmm.
You might store information, media, whatever in Amazon Web Services, but then it might end up in your web application, your mobile application, etc.,
Hmm.
distributed maybe in real time, maybe not in real time, but it ends up where your users are seeing it, having it served, etc. But the burden of storage and all of that is handled elsewhere. You have to like map what would be a local file system to that content delivery network. How close was that?
That was pretty good. Yeah, I mean, you have that base concept nailed, and that really is what the CDN is all about, and that's where it started. So that's what's interesting about the CDN is so it started as purely that, right? Just content delivery, getting latency down, and providing the ability to deliver that content at the edge. So we talk about that a lot in the cloud. Is a CDN is what we would call like edge computing, if you've heard of that. So it's getting data and maybe presentation to the edge and really close to users. What's interesting is that CDNs don't just do that now. So while they started there, what's the next logical thing? Or really, goes hand in hand with getting that data at the edge is caching. So
Right,
one of
right.
the biggest benefits of a CDN is around caching. And so why I said the edge is important because compute's expensive and we don't want to redo work. So if I have got a globally distributed system and most of the users are going to see a very similar homepage, maybe except for some unique personalized attributes. I don't want to redo and re-go back to my AWS instance that you're talking about just to get the homepage. So instead, we're going to cache that locally at the CDN. So that's one of the main things. Now, we do that for JavaScript, CSS, and additional files as well. It reduces bandwidth at what we would call our origin server. But that's really the first main big benefit that a CDN. So
Okay.
to
At the
give
risk
you,
of oversimplifying, we've gone
yeah,
from having certain pieces of content or information at the ready to having larger units of information, to having a whole homepage, for example, at
yeah.
the ready, cached, prepared to be served up. It's the same concept, but like you said,
Mhm.
with the more advanced framework and therefore more benefits to it. Yeah.
Exactly. Yeah, and you don't have to do an entire page rate, and like depending on different applications, they can do things differently. But in the case, we previously talked about GraphQL, like we can cache API responses as well at the edge,
Totally.
right, for a CDN. So now it becomes very interesting, and at the edge, we talk about CDNs helping us unlock scaling. Globally, so like hyperscaling capabilities in
Can you define
system
hyperscaling? This is a
architecture.
mean question, but like,
Yeah. Well, hyperscalers, by definition, or what the industry uses them is they would talk about like the main cloud platforms. So in North America, that would be AWS, GCP, Azure. In China and Asia, that might be things like Alibaba, Tencent. Those would be called hyperscalers. But what I was talking about for hyperscale was more this concept of using the edge of the cloud and these cloud distributed systems like a CDN to allow us to scale well beyond our core systems capability and our core origin compute capacity. So I use the term maybe not the same way the industry would use, but that's what I would call hyperscaling, right? We have the ability to hyperscale our origin system by using something like a CDN.
hyperscaling doesn't have like a mathematically correct definition. It just means
Yeah.
being able to scale a lot really
Yes,
fast, right? When you
that's
get
right.
right down to
Yeah.
it.
Yeah, and I would, in fact, say CDNs fall more in the camp of a hyperscaler than
Hmm.
the cloud system. Like the cloud systems all provide CDNs, so you could say they are hyperscalers, but traditionally, when folks talk about hyperscalers, they're talking more broadly in the sense of CPU compute, which in this scenario, we don't want to redo work. What's interesting is, so now you've got this main concept of caching in the CDN, but there's a whole host of additional things CDNs do. So if I were to talk to you about security, so we have requests coming to the system and they're hitting a CDN first. What's the next natural progression? Well, we should probably have a firewall there to either block or filter traffic before it even reaches our origin system. So that's another key component now that CDNs have kind of taken on. Of course, we could do that separately, but most CDNs now, or in concert like Cloudflare, Google CDN, Akamai, AWS, they incorporate security. And it makes sense, right? We can block traffic at the edge; it never reaches our core, and we don't pay for that compute if it's either invalid or we don't want it.
For people who are watching this who maybe are coming into the concept new, right? I do
Yeah,
want to highlight something you're saying, which is that like you said, what's the next logical step? It isn't just having more information cached, but it's moving
no,
from the idea of having information in the external network, away from the origin system, to having computational power
yeah.
offset, having actual, like you say, compute take place elsewhere. That seems to me like that's where we start getting into what cloud computing actually means as like a meaningfully different concept from traditional computing or edge for that matter. Yeah.
Exactly. And if you're going to build a truly global distributed system that can handle scale, you can't do that without a CDN. And you also must understand these concepts because you have to be able to respond, obviously, quickly with the information that's required, but you need to prevent inbound even reaching your source system. It's not financially viable to just scale CPU out, and we hear a lot about auto scaling, right? And you'll hear it a lot in cloud architecture. We can scale CPU and Kubernetes and all sorts of fancy words. But what's better than scaling compute on your origin is not having to, because
Mm.
you've used the cloud and these hyperscalers that provide CDNs at the edge to prevent that traffic from even reaching your system.
Yeah, absolutely. That makes a ton of sense. That makes a ton of sense. And this is kind of we've talked about the cloud on here before, but it isn't, there's that old saying that the cloud is just someone else's computer, right? Which is
Mm-hmm.
like true as far as it goes. But when you
Yeah.
have computers with divisions of labor that make sense, right? The origin system and then something else really, when you have clever routing of the work and then the work being done in enormous batches with the scale being able to change, as you say, automatically and very
Mm-hmm.
quickly, that does unlock genuinely new possibilities, right? There's
Well, it's a
there's
different
something
paradigm
to
of
yeah,
compute,
yeah,
right? It's a different paradigm. It's not 2005. We respond to every request by recomputing
right.
what you want. Now it's either we're pre-computing or we're responding, and if you just want something static or something kind of normal that we know about, we'll just respond at the edge to that. And, hey, the origin will just update it when it needs to,
Yeah.
either in response to some event. And that's kind of a broader topic that we'd have to take is, that caching topic can get really deep, right? Is how do we update that cache in the
Yeah.
CDN? And do we update it in response to events, or do we use things like time to live and TTL and cache expiries? And that's a much broader concept that we won't get into today.
Let
But
me zero in on something different. I'll look dumb one more time. Pre-computing. My understanding is that the idea is to sort of try to predict the work you need to do once we talk about offsetting computation to the edge of the cloud or what have you. The idea is in the same way that we're no longer responding to every request, we're now also not necessarily just offsetting in real time either. We're trying to figure out ahead of time what needs to be done and then doing that work before the request comes in. Is that, again, close?
exactly, yeah, no, and it is, and that is again, how do you design a true system to scale? Like
Totally.
that's a hyperscaling type of scenario. So I'll give you a very concrete example. Again, we're getting deep, but let's imagine we have a new, so in an e-commerce domain, let's imagine we have a new shipment that arrived at a depot and we're replenishing inventory and the inventory's now been received. The item is out of stock on the storefront. That page is globally cached as out of stock.
Mm,
Okay. You could add to
yeah.
cart. And so now the inventory is coming inbound into the e-commerce platform. An event's now triggered. We now know the inventory is coming in. The system's updated. But now we have this distributed network of nodes that have what's called a dirty state. The pre-computation would be, let's not wait to actually have that cache expire, right? And then go and update it and go get the new inventory and then cache it, right? And then roll that out. Let's say, oh, we know new inventory came on this item. Let's regenerate that cache page and let's publish it out. And we pre-computed it. So there may be a time period, if it's near real time where somebody got a stale page for, some seconds, but eventually that page will pre-compute, that pre-computed page will update, and now we have a consistent state that came in. And that this paradigm, this goes more broadly to system designs, event-driven architectures, all these things. But what I think is CDN being at the edge exhibits, the behavior of our overall system design. And so, yeah, quite interesting, interesting concepts. I think we got a lot deeper than just the definition, didn't we?
I think we did. I mean, well, hopefully, let us know. This is being posted somewhere with comments. Let us know if you like these deeper discussions. We're happy to do more of them. Let us know if you like Erik putting me in the hot seat and having me look dumb in front of people, because we could do a lot more of that. That's easy.
No, you did
Um,
you did well. You knew the concept and all the basics. I think it's
No, it's
just
like it's so easy for your information to get out of date about some of these things, right? You think you know, and then you like if you haven't updated your understanding, the technology moves forward, and it's like, oh yeah,
Mhm.
yeah, yeah, that's true, but also the following things have become true as well. So these kinds of conversations are like super helpful for me. I hope the people watching find them helpful too. Thanks, Erik.
Awesome. Great. Thanks, Drew.